So, hello everybody. This is Przed from Novismo, and today we're going to talk a little bit about certification level 2 seminar that is going to take place soon. We have Sergei Ikovenko here, who just will tell us give us some information about what materials what we're going to learn at this certification level 2 program, and maybe some about the examination. After all, we will give you answers for your questions you're going to put on YouTube chat or give us via email. So welcome again, everybody, and I'm hello, Sergei. How are you?
Hi guys. I'm good.
Yeah.
All right. May I start, right?
Yeah. Sure.
All right. Yeah, I'm at General Electric right now. That's why I can just speak. And Przemek will be actually driving the slides, as I move through the presentation. So what I wanted to talk about today a little bit about this level 2 TRIZ certification training. Actually, several months ago, TRIZ has changed the requirements. So this class will be one of the first according to the new requirements of level 2 of International TRIZ Association certification. So slide number 2. Maybe some of you have seen it. It shows actually how chronologically TRIZ has been evolving. First, the problem-solving tools developed by Schuler, resolving engineering contradictions, physical contradictions, ARIZ, trends of engineering system evolution. Then analytical tools that became an intimate part of TRIZ, actually the most important part at this point, function analysis, trimming, cause-effect chain analysis, feature transfer. Then later different applications were added to TRIZ about, for example, walking around competitive patterns, pragmatic S-curve analysis, and so on. And later, the new addition to TRIZ that is becoming a part of it, something that links TRIZ and the market needs, how to identify hidden needs of the market. So that's the whole picture of modern TRIZ evolution. And if we move to slide number 3, it shows the same tools, but now how we use them within a project. So there are a number of analytical tools, then problem-solving tools, and there are things to do after ideas have been generated about resolving secondary problems, IP issues, and so on. So level 1, that's what's shown on slide number 3. These are the tools that are covered by level 1 training. If some of you attended level 1 certification training, you have mastered or at least learned, these tools. Out of the analytical tools, we studied function analysis for devices, how to create component model of our device, how to build function model, how to formulate functions, how to rank them, and so on. Then we discussed cause-effect chain analysis, because function analysis gives me a lot of different issues. Some functions performed insufficiently, some harmful functions in our system. So I can have 20, 30 of different issues, but I'm not going to solve all of them. I don't need that. I can arrange those issues into chains, because usually one issue gives birth to another, and so on. So the results of function analysis are arranged in chains, and cause-effect chain allows me to find that key disadvantage, what sits in the beginning of the chain. So when I resolve problems, I will focus on those, the problems from where the headache was born. Then we learned trimming, how to do trimming, because it would be a very nice approach to not to resolve a key disadvantage, not to resolve the problem, but to trim a component responsible for that problem, and the problem will disappear itself. But the trimmed component perform some function, so we need to take care of them, teaching remaining components perform them. So trimming teaches us different trimming rules and approaches. So that was taught during level 1. Level problem solving tools for level 1, it is modeling the problems as engineering or technical contradictions and physical contradictions. Also, we learned how to do that, and also how to use the tools for resolving the contradictions, Aljour's contradiction matrix, different ways to resolve physical contradictions in time, space, system level, and some new things that have been developed within the last 3-4 years. For example, resolving physical contradiction in directions. So these are the tools of level 1. And if we go to slide number 4, these are the tools that we will learn during level 2. You can see function analysis is here again, but it is a different function analysis. It is function analysis for technological processes, because for many companies, they improve not just devices, but technologies, manufacturing processes. For example, Procter & Gamble, they manufacture paper. They don't change the recipe of the paper. That's why the improvement is not about the paper. It's about paper making process. Or they make soap. They do not really change the formulation of soap, but they improve the technological process, how to do that. And the function analysis for technological processes has its specifics, its nuances. So we will learn how to do function analysis for technological processes, analyze different operations, how to evaluate different operations of the process, calculating their value, how to trim operations, and delegate the functions from one operation to another, and so on. So function analysis for operation, it's one of major topics of level 2. And we will, if we go to slide 5 and 6, and 7, these are several slides that describe the project that we will be analyzing. These are, by the way, practically all the examples and projects that we discussed during level 2 are real projects that we had with either Procter & Gamble or Kraft's Food or GE or Hyundai Motors. So everything is not examples from books, but real projects, and there are solutions and patents generated as the result of the project. Specifically, we will talk about this soap project, from Procter & Gamble. They developed a very unique soap that doesn't get soggy in water. But there were some issues with manufacturing this soap, and we will be in detail learning function analysis for processes on this example. Okay, now slide number 8. Slide number 8. Another tool that we will cover during level 2, it is feature transfer. Feature transfer, if you ask me what it is, and I have like 1 minute to explain, slide 9 shows what it is. When I have a system with some issues, so instead of doing all these, complex analytical process, function analysis, trimming, all that stuff, there is a shortcut. I can, in a specific way, I can do benchmarking and find systems that have opposite pluses and minuses in comparison to the system I'm going to improve. For example, if you look at this slide 9, you have a cabbage. You eat cabbage that is on top of the ground, and we never eat roots. So there is something, a part of this vegetable that we do not use. And we can find another vegetable, carrot, and here we have a mirror images of pluses and minuses. We eat the root, but we do not eat the top. And feature transfer, if Przemek, click several times, you will see the idea is to create a vegetable that combines advantageous features but does not have the disadvantages. Of course, it's a joke, but it illustrates the concept of feature transfer. It is not easy to do that, because usually when you stick things together, like I did with cabbage and carrot, there are contradictions. Some things contradict. That's why it is necessary to resolve the contradiction to generate a solution. So feature transfer, or another name for it, hybridization, discusses the details of this method. And we will also look at different nuances and advanced techniques that are described on slide 10. How to do this feature transfer multiple times. So we can have several parents and we just extract advantageous features from different parents and stick everything in one. So in the long run, we will have a hybrid that is the champion for all the parameters, the smallest, the cheapest, the most efficient. Then how to do a feature transfer on processes, because we will learn everything about processes during level 2. Then there are different levels of sophistication. I can transfer the feature together with the physical component, or I can do it in a very inventive way, transferring pure feature without any physical component, like a ghost, of the feature. So we will discuss these different levels of sophistication, how to transfer feature together with the physical component and how to transfer fewer feature, or there is something in between. We transfer physical component, but in the form of a mixture. It is called mixtures. And the last nuance, this is something that is very newest development in TRIZ that was developed like a year, 2 years ago, how to combine my system with so-called neutral system. Because if I have something negative in my system, one of the approaches is to dilute this minus. If I have very salty soup, I can not just remove salt, but I can dilute this soup with water so it will not be salty. So how to do all these different techniques during hybridization, that's the major focus of this feature transfer topic. Then another very big topic, a major part of TRIZ problem-solving techniques, it is a system of standard inventive solutions. That's a very powerful tool. Some people are scared of it because it is not really very well described in books. Some people think it's overcomplicated, too many of those standard solutions, they cannot navigate through them because there are 76 of those recommendations. But, there is a navigator, how to actually use that, and some standard solutions are used most often, practically in every project. So what we will do when we learn this tool, first of all, we will get familiar with different classes of these standard solutions, and then instead of kind of embracing all 76, that is impossible, we would focus on 3 or 4 most often used, the strongest standard solutions from every class. So you will have them at your fingertips, like, they do it at Samsung. They have like a memory jogger with just 3 or 4 standard solutions from each class. That is why, this tool is used there and can be used by you very, very efficiently. The last big, not a big topic, but important topic, it is introduction to ARIZ, algorithm for inventive problem solving. ARIZ, it's also is a scarecrow. It's a scary thing, and many people say that is very difficult. We cannot use it, and they just refuse learning it. But ARIZ is a major part of level 3. Actually, ARIZ is a very powerful tool. There are 3 very important claims to fame, very important things about ARIZ. First of all, it allows us to do the following. It takes a problem that we want to solve, and as we go through this algorithm step by step, we will remodel the same problem in all different ways that TRIZ offers. We remodel the same problem as technical contradiction, as physical contradiction, as subfield, as a function. And as we remodel the same problem all these different ways, we will have a chance to use all these different tools, contradiction matrix, standard solutions, resolving physical contradictions, and other things. That's why usually ARIZ is used on difficult problems, because we use everything. No stone remained unturned. That is why usually it generates ideas, more ideas than any other TRIZ tool. The second claim to fame of ARIZ, it is focusing on achieving so-called ideal final result. We solve a problem and we change the initial system minimally. Ideally, don't change it all. Usually, manufacturing people love this approach because it's a dream. You resolve your problem and you have not changed much in your initial system. How to do that? The only way to do it is to use only the resources that I already have. I'm not allowed to bring anything new into my system. I must utilize the available resources. That's why another strong side of it is very rigorous, very detailed analysis of the resources that we have. We maximize usage of resources, try to use combination of those, and there are techniques how to do it. So resource analysis is very strong there. And the third claim to fame, of a RIS, it is the ability to find new physical contradictions, because we find those contradictions about the resources. That's why usually a RIS finds these new physical contradictions that results in many more new ideas. If we look at slide 14, there is a strategy of two cones. Alschuler usually had been talking about these two cones, but if you read the TRIZ books, there is no explanation about that. What he meant by two cones, you can see this picture of two cones. One cone is converging, it is getting narrower, 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 and narrower to to the peak point. That's the cone of formulating the problem. So we start with kind of fuzzy problem that came from the analytical part. And then as we remodel the problem again, and again, in the long run, we have very crisp, very clear model of the problem. And the second cone that is diverging, expanding, that's the cone of resources. We find more and more resources that we can use to solve the problem. That's why in the end, at some point of a RIS, we have on one hand, our problem modeled very clearly, very clean and precise. And on the other hand, we maximize the resources that are available to us for solving this problem. At this point, that's the best, the most convenient, the most efficient to generate ideas. So what we will have during level 2, it is introduction to a RIS. Full-blown RIS, it's a major topic of level 3. But to explain people the power of RIS, what is the major strategy, what is the major philosophy behind the RIS, so they're not scared. And also, by the way, the first part of a RIS, it's very, very, instrumental to be used even separately, just based on the knowledge from level 1 and 2. So that's kind of briefly the major topics that we will have during level 2. But of course, we have, we will refresh on the way things, from level 1. If someone took level 1 or is know those topics, but they maybe a little bit faded away, you forgot something, we will be refreshing things on the way, from level 1. And of course, because it is a certification program, there will be a certification test in the end, official test of the International TRIZ Association based on material of level 1 and 2. If you had taken level 1, you know what this test is, more or less the same thing. There will be a number of questions, usually multiple choice questions. That's why it is not that scary. You will get the official international diplomas of the International TRIZ Associations, and of course you will be encouraged to practice TRIZ more, and the gate will be open for moving further, to level 3 and so on. Also, if you are interested in specific applications that we mentioned, specific types of project, patent circumvention or failure anticipation or something, we can always, find time and elaborate, talk more about that or another topic that interests you. Yeah, so on one hand, of course, there are predetermined topics that we must cover. On the other hand, if some topics or aspects or type of project or industry, because there are some different best practices in using TRIZ in microelectronics, or like a GE or automotive industry, primarily at Hyundai or Fiat. That's where TRIZ is being deployed very aggressively right now. We will have a chance to discuss those things too. All right, so that is briefly about this level 2. thing. So if you have any questions, any specific questions, I will be more than happy to answer.
Yeah, okay, thanks very much, Sergei. I have a question, but if someone from the audience have any questions, please find the way to give us any questions on the YouTube chat, maybe Facebook or our bureau email. So any way you like it, please give
or
us questions.
Email to me, whatever.
Yeah.
It does not matter in what format. I will reply because I'm going home back to Boston today, so I will have a chance to answer all the emails.
Yeah. So if you have any questions right now, just put them on the chat. But if you don't, just but you remember something you would like to ask, just give us or Sergei the email so we can answer your questions. But to be honest, I have one question because you told us that this level 2 exam will take the examination rules changed a little bit recently by the TRIZ organization. Could you give us a little bit information what have changed?
Oh, it is not the rules that change, but the topics, what
Oh.
is required for level 2. Because, for example, technological processes, in the past, it was a requirement for level 3, but many companies actually requested to put it into level 2 because they are process companies and they can do nothing actually without this. That's why function analysis for processes was moved from level 3 to level 2. Then feature transfer. In the past, it was within level 1, but it was too much for level 1. That's why level 1 was a little bit unloaded. So feature transfer was actually moved to level 2. So it is not the form of the exam that has changed, but the list of necessary topics to learn.
Yeah, sure.
So that's the major change. Mm-hmm.
Okay. Thanks very much, Sergei. I don't see any questions right now, but if you guys want to ask questions, I encourage you to just write to us and we will give you the answers as soon as they pop and we have answers. So thank you very much, Sergei, for today. Thanks for you found time to meet with us and talk with us a little bit about this this course and the examinations. Yeah. Thanks very much.
Thank you, guys. It was a pleasure.
Yeah. Okay. Thanks.
All right.
See you next time. Bye.
Bye-bye.